Welcome to The Explainer. We're all about breaking down the big ideas. So, is a city on Mars just science fiction, or is it actually our future? Well, today we're diving headfirst into SpaceX's incredibly audacious plan to find out. We're going to look at the vision, the unbelievable machine they're building to get there, and, of course, the massive challenges standing in the way.
All right, so first things first, the vision. Let's really dig into the breathtaking goal that's driving this whole thing.
You know, the scale of ambition here, it's just staggering. We're not just talking about planting a flag or, leaving some footprints. The real long-term goal is to build a completely independent second home for all of us, a genuine backup for civilization.
And get this, the timeline is wildly aggressive. I mean, they're talking about going from the very first uncrewed cargo missions to landing the first crew on Mars in less than 3 years. That pace, it's pretty much unheard of in the world of space exploration.
So, the big question is, how on earth are they even planning to pull this off? Well, it all hinges on one single absolutely massive and truly revolutionary machine.
Okay, say hello to Starship. This thing is the beating heart of SpaceX's entire multi-planetary plan. It's not just the ride to Mars, it's also the future habitat, and it's designed to completely, and I mean completely, rewrite the rules of space travel.
Just to wrap your head around the sheer scale of this beast, get this number. When you stack it on top of its super heavy booster, Starship stands over 120 meters tall.
Yeah, that's taller than the Statue of Liberty. We are literally talking about a skyscraper of a rocket. It's just immense.
And the progress they're making is just moving at lightning speed. In 2025 alone, they ripped through 5 major flight tests, and each one was methodically ticking off a new engineering goal, from working on the heat shield to trying that insane booster catch with the launch tower. But look, its incredible size is really only half the story. The real game changer, the thing that makes the economics work, is its reusability. The whole point is to make it operate less like a throwaway rocket and more like an airliner. Fly, land, refuel, and fly again, really fast.
Okay, but here's the reality check. Despite all of this amazing progress, the hardest, the most dangerous, and frankly, the most uncertain parts of this whole journey, they're all still ahead.
Actually, the mission's entire success really hinges on getting through this gauntlet of 5 huge, totally unproven engineering challenges. These are the 5 great hurdles standing between us and a city on Mars. And they range from just getting to orbit all the way to making fuel on Mars itself. That's the ISRU part. So let's look at the first 2. For starters, the ship has to actually get into a stable orbit, which, believe it or not, it hasn't successfully done yet. Then, once it's up there, it needs to get refueled for that long 6-month journey to Mars. And that involves a maneuver that's never, ever been tried on this scale before.
And we're not talking about a small top-up here. No way. We're talking about transferring around 1,200 tons of super-chilled propellants from one ship to another, all while they're both zipping along at thousands of miles per hour in zero gravity. The degree of difficulty is off the charts.
Just think about what that really means for a second. To get all that fuel up there, it's going to take somewhere between 10 and 20 separate tanker flights from Earth for every single ship they send to Mars. The logistics of that alone are just mind-boggling. All right, on to the next big hurdle, the landing. This is, you guessed it, another monumental challenge. You've got Mars's super thin atmosphere, which doesn't help you slow down much. You've got a heat shield that's still basically in testing. And you're trying to land a skyscraper on rocky, uneven ground, a place where we've had trouble landing tiny rovers. And this chart right here just shows you the insane difference in scale. Just look at the mass. We went from landing things that weigh, less than a ton, like Viking or the Curiosity rover, to now trying to land a vehicle that weighs over 200 tons. It is a completely different universe of difficulty. And then, finally, if they even make it to the surface, the last 2 hurdles pop up. First, a bunch of unproven humanoid robots are supposed to autonomously set up the entire base. Then these massive resource production systems have to work perfectly to make fuel for the trip home. And all of this has to happen in one of the most brutal, unforgiving environments we know of. So, with all these huge challenges stacked up one after another, what do the experts really think? Is this timeline realistic? Is this dream even within our reach? Well, on one hand, a lot of experts in the field absolutely praise the basic idea. They agree that focusing on this massive scale and full reusability is a huge step forward.
It's probably superior to any other Mars plan that's ever been put on the table.
But on the other hand, you've got people who are deeply skeptical, especially about that timeline. A lot of veteran Mars experts point to that whole gauntlet of unproven tech we just talked about and basically say the 2026 launch date is, well, nearly impossible. They think a delay of several years is way more likely.
And what's really interesting is that Elon Musk himself has put the odds for that first uncrewed mission in 2026 at just 50-50. I mean, that's a pretty candid admission of just how incredibly difficult this whole thing is going to be.
Okay, so for our final section, let's pull back and look at the bigger picture here. What's the true goal of this whole journey?
And this really gets to the heart of it. The real takeaway might be this. It almost doesn't matter if Starship launches in 2026 or 2029. The relentless pursuit of this goal is already pushing technology forward in huge ways, in robotics, in material science, in propulsion. The journey itself is reshaping our future in space. And that leaves us with one final thought to chew on. Maybe the true destination isn't actually a city on Mars, but all the incredible innovation we're forced to create just by trying to get there.